Last video for this week, 15D, the quotient rule. So quotient functions are in the form. I'll use a capital Q of x to represent this quotient function. It's in the form u of x divided by v of x. So one function divided by another. Okay, notice that. Let's take a look at the proof of this. It's quite interesting. Notice that u of x, just rearranging this equation for u of x, we would get u of x equals q of x multiplied by v of x. Okay. Now using the product rule, we could take the derivative of u, and it would be derivative of q multiplied by v plus q multiplied by the derivative of v. Okay, now what we're actually trying to find here is the derivative of q, so we need to isolate that. So q derivative times v equals u derivative subtract q times v. Divide both sides by v gives us derivative of q equals u subtract q v all over v. But notice that q is equal to this. Okay, so let's substitute that in right here. So u subtract u of x over v of x times v dash all over v. We need a common denominator in that numerator. So u x vx over vx subtract ux vx over vx, which is all over vx. And the final step then is the derivative of q is equal to derivative of u multiplied by v subtract u multiplied by derivative of v all over the derivative of v squared. Okay, written more simply without all those x's in there, u dash v subtract u v dash all over v squared. This is the quotient rule. Finding the derivative of one function divided by another function.